Right, before moving on to the next example, I wanted to fix this misspelling because it's bugging me. So there we go. And I don't like this hyphenation here either, so let me change that as well. Oh, nope. There we go. All right, so let's do the next example. Security checkpoint signage. The Transportation Security Administration would like to speed up security checkpoint lines by reducing the number of banned items, liquids, sharp objects, weapons, etc., that show up in carry on luggage. It tests two formats of the signage along the security line that remind travelers about banned items. Signage pattern one would be smaller signs that are spaced 20 feet apart. And then signage pattern two would be large reminder signs spaced 40 feet apart. The sample is 48 security checkpoints at various airports in the US, and the checkpoints are matched on airport size and daily passenger traffic. And so this would result in 24 matched pairs of security checkpoints. Our dependent variable would be the number of banned items appearing at checkpoints during a 2-week test in thousands of items. And here's our research question. Which of the two signage formats results in fewer banned items appearing at security checkpoints? And our null and alternative hypotheses are similar to the previous example. In the null hypothesis, we're saying that the average difference in the number of items between each pair of checkpoints is 0, and then the alternative is that the average difference is not equal to 0. Also note that we have 24 different scores in our sample, one for each pair of security checkpoints. Now we're going to go through the assumptions, the assumption tests. For 1 and 2, let's start there. We are looking at the level of measurement. For the dependent variable, remember that we want it to be interval or ratio. In this case, we are looking at the number of items. We're just counting that. So this is ratio, so we're good there. And then dependence of samples. This example involves matched pairs. Step 2, examine distribution of different scores for presence of outliers. We calculate a different score for each pair of observations, and then we'll turn the different scores into z-scores, and then we'll run frequency distribution of the difference z-scores. And in the next page, let's check out our output. Looking at the z-scores for the 24 different scores, we're looking for anything that's beyond plus minus 3.29, and there are none, so there are no outliers in this data set. Now we're going to look at the skewness. It's 0.01, so that's less than the absolute value of 2, so that's good to go. So with all of those different items met, the assumptions, we are ready to perform the statistical test and then examine output. So we'll look at our descriptives here. The SS stands for small signs, and then LS is large signs. And recall that our unit of measurement is in thousands. So we see that the large signs resulted in fewer banned items. So let's put that here. Large reminder signs, because that's got a lower mean than the one above it. Okay, so given these numbers here, we want to know if this difference is also likely to occur in the population of all security checkpoints. Because remember, right, we don't care what the sample says because samples lie. So we're going to find out the answer to that question by running a paired samples t-test, and here's the output. So what's our conclusion here? Do we reject or not reject HO? Well, looking at the p-value, it's less than 0.05. So yeah, we're going to reject this. It has a t-value of 7.8462, so that's pretty high, pretty big. What? Yeah, reject null hypothesis. What's the interpretation of the confidence interval? Okay, so here it is right here. Remember that we are dealing with thousands in units of measurement. So let's put the confidence interval this way. We are 95% confident that the difference can be as small as, okay, so it's in thousands, 575, or as high as 986. Our overall conclusion based on this output, okay? Large sign. So remember, right, we rejected the null hypothesis. We're saying that there is a difference, or that it's not equal to 0. That's what I meant to say. The difference between the two. So because that was the case, we look at the means and say, okay, well, which one is higher, which one is lower? So in this case, large signs is more effective because it had a smaller amount of confiscations. Is that right? Confiscate? Yeah, whatever. So let's say large sign format is more effective. Refer to means. And that's what I did just a second ago. LS format, so large sign format, reduced banned items by as few, so I'm just repeating what I said here, by as few as 575 or as many as 986 items in the population. All right, so next topic is the effect size. So we don't do that for the dependent samples t-test, but we can still look at the practical significance, which could get pretty interesting. So in this case, how many fewer banned items in the large sign format versus the small sign? Well, let's look at the mean difference right here. So in thousands, so it actually resulted in 781 fewer items. Over the course of 14 days, we're talking 55.8. 55.8 per day per checkpoint. Well, is that significant? We don't know. The TSA would have to take a look at that and say, or make a conclusion, right? Hopefully, they have more information that will tell them whether that's good or bad. Like, is that significant that in implementing these two different signs, that the large signs are better in reducing up to 56 per day? Yeah, we'll see, right? So that's up to them. And one way for them to look at the practical significance would be to examine the average time and personnel cost required for each banned item and then calculate the savings per day. So perhaps that could be one metric for measuring its significance. Now, as far as graphing the results so you can show your manager, it depends on the context. So you could show the overall difference that it made in 2 weeks, like we see in this graph right here. So 15,895 versus 15,114. So those numbers were from the descriptives here. Or we could do it per day, which is what this one shows right here. All right, in the next video, let's do the last example. Safe point security sales performance change over time.